All right, 8.1.2. I just want to take a little bit of time here to show you another strategy for finding the greatest common factor. So I have just some Delta Math examples that I've pulled screenshots straight from Delta Math. So these are exactly like the kinds of problems you'll be seeing. So remember, when we're looking for the greatest common factor, we're looking for what numbers multiply to make 10 and what numbers multiply to make 45. And like, what's the largest number of those factors? Those are called factors, the numbers that multiply to make other numbers. What's the greatest common or the largest number in common that we could divide out from both of these? So again, when we're working with these, what we want to do is we want to look at our smallest of the two. So out of 10 and 45, 10 is smaller. And so I'm going to list the factors of 10. Now you may know them in your head. You might be able to look at this and just tell automatically, but I'm going to list them so that we can see them. So we have 1 times 10 makes 10. We also have 2 times 5 makes 10. So these are our factors of 10. 1 times 10 and 2 times 5. And we're going to start with our largest factor, and we're going to see if it goes into 45. If it doesn't, then we're going to cross it out and try our next largest factor. So 45 divided by 10 does not work. 45 divided by 5 does work. So 5 is our common factor. It's our greatest common factor. So check this out. This is the new piece that we're going to talk about. Using 5, I want to know 5 times what makes 10 and 5 times what makes 45. So we have 5 times 2 that makes 10. And then it's also multiplying with this x here. So I'm going to leave this x as well. So 10x can be rewritten as 5 times 2 times x. Means the same thing. We've just, the same way that $20 can be a $20 bill, but it could also be 2 $10 bills. It's the same value. So here we have, or a $10 bill, right? You have a $10 bill, or you can have 2 $5 bills, a $5 bill times 2. So with 45, and this is negative 45, so I'm going to leave a negative here. 45 is 5 times 9. So I'm going to give us a 9 here, right? 5 times, we can rewrite 45 as 5 times 9. So then we're looking for what's in common. So what we have in common is a 5, right? And we circled that here. So if I were to take this 5 out from both of these, so they both have a 5 to give. So if I pull a 5 away from them, I'm going to cross that 5 out, and I'm going to be left with a 2x, and I'm left with minus 9. And that's my answer. So let's try that again. When we're finding the greatest common factor, we're going to look for the smaller of our two numbers. So the smaller one here is 14. I'm going to list my factors of 14, 1 times 14, and 2 times 7. And then we're going to compare. So will 14 go into 49, or can 49 be divided by 14? And it cannot. So that's no good. Okay, can 49 be divided by 7? 49 divided by 7, and that does work. It leaves us with 7. So 7 is our greatest common factor. So I want to know 7 times what makes 14, and 7 times what makes 49. And then we're looking for our common factors. So here's what I have in common. I have 2 7s in common. So that's what I can pull to the outside. So when I pull them to the outside, you could like cross them out. And then we're looking at, well, what's left over on the inside? We have a 2, right? That came from here in red, so 2. And then from my blue here, or actually green, I have plus 7x. So this was a plus sign in between here. So I have a plus 7x. 7 times x is 7x. That came from the green. So this might be easier for you to see what's left over by splitting these up this way. So we have 18 here. That's our smaller of the two numbers. It's smaller. And I'm going to list the factors of 18. So I have 1 times 18, 2 times 9, 3 times 6, and 4 doesn't work, 5 doesn't work. So these are all of our factors. So now I'm going to compare. Can 63 be divided by 18? And it cannot. You got a decimal. Can 63 be divided by 9? And it can. So 9 is our common factor. So I'm going to use 9, and I'm going to break this as 9 times something times x, and 63 is 9 times something. Okay, so 9 times 2 makes 18, and 9 times 7 makes 63. So my common factor here is 9. So if I'm going to divide out a 9. That means I can take a 9 away from both of these, and I'll be left with 2x plus 7. I did have a plus sign here. So my final answer is 9 times 2x plus 7. So if you liked doing the other way and not writing a little tree, that's fine. But this kind of helps you see what we're doing mentally. Okay, last time I taught this, or the last video you watched, it was like some mental math. Now you get to see what's taking place here. Okay, so I'm going to pick the smaller of my two numbers, so 30. I'm going to list my factors of 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, and 6 we're back around. So these are all of my factors of 30. And then I'm going to see which one, what's the largest factor of 30 going this way, what's the largest factor that goes into 42. So 42 divided by 30 would get me a decimal. 42 divided by 15 would get me a decimal. 42 divided by 10 would get me a decimal. 42 divided by 6 is 7. So you could just go through your calculator and divide them out until you get something that works, or you may just know your factors. So 6 is my greatest common factor. So I'm going to rewrite 42 as 6 times 7. And then my x squared is staying the same, so times x squared. And then I'm going to rewrite 30 as 6 times 5. And we're looking for what's the common number that we can take from both of these. It's 6. So if I were to divide out a 6, right, and that means, well, I probably shouldn't use x's because they look like, then here's what we have left over. We have 7 times x squared and plus 5. So we're just writing what's left over. So again, let's try this one. We're looking at 30 is smaller than 100, so I'm going to take my factors of 30, which I already listed in the last problem, right? 1 times 30, 2 times 15, 3 times 10, 5 times 6. And I'm seeing which one of these, what's the largest one of these that will fit into 100? So does 30 go into 100 evenly? 100 divided by 30 does not work. It gives me a decimal. 100 divided by 15 also gives me a decimal. 100 divided by 10 works. 100 divided by 10. So if I use 10 as my common factor here, and then I have my x squared still, 10 times 3 makes 30, and 10 times 10 makes 100. So it's my common factor that I'm writing on the outside, and then it's my leftovers that gets written on the inside. All right, just a couple more examples. This one we have variables that we're going to be dealing with as well. So the first one's covered numbers. These ones also have common variables. So let's check this out. I have my smaller of the two is 2. And I could list these 1 times 2. I'm going to see if my largest one fits in 10, and it does. 10 divided by 2 works. So I'm going to break this into 2 times 5 times x to the 5th minus 2 times 1. Do those in blue. Times x. So if I break these down, this is really 2 times 1. This is really 2 times 5. And I'm looking for my common variables that are my common numbers that I can take out, which is a 2. And I also have x to the 5th and x to the 1st. And so my common x there, think about x to the 5th being, and x to the 1st being like this. I can take 1 away. And if I take 1 away, I can scratch these out. And then I have none left on this side. I have 4 left here. So I'm saying 5 times x to the 4th. So left over I have 5 x to the 4th minus 1, because that's all that's left over here. This x went away. All right, last couple examples. So for this one, 21 is smaller. And we're going to be able to pull an x to the 2nd out because we can take our smaller variables. So I already know here x to the 2nd. Maybe I don't know what the easiest way to do this is. And that's going to leave me with an x to the 2nd here because I'm doing 4 minus 2. And x to the 2nd means I'm not going to have an x term in my first term. And then 21, we can split into 1 times 21, 3 times 7, and those are the only ones that work. So I'm going to compare. I'm going to say, can 70 be divided by 21? It cannot. Can 70 be divided by 7? It can. So 7 is my common factor. I'm going to say 21 is really 7 times 3. And 70 is really 7 times 10. So my common factor here is 7. So I can write a 7 on the outside. And I have 3 plus 10 left over. And we already had sorted out the x values. So I don't know which order you'd like to do that. Okay, for this one, we have a negative in front. So we are going to take out a negative. So whatever our greatest common factor is, we're going to use the negative of that. We just like to use the sign of the front number. So smaller of the two is 7. So I'm going to list 1 and 7, and I'm going to see, can 7 go into 10? Can 10 be divided by 7? And it cannot. Okay, so the only option is a 1. So 10 can be divided by 1. So I'm going to rewrite these, but I'm going to rewrite them with the negative. So a negative 10 is really just negative 1 times a positive 10. And I leave my x. And then a negative 7 is really a negative 1 times a positive 7, x to the 4th. So my common factor here is a negative 1. Oops. And what I have left over, actually, hold on. So that's my common number, my common variable. So I'm going to highlight in purple. X to the 1st and x to the 4th, I can pull an x to the first out of both of those. And that's going to leave me with 10 plus 7 x to the third, because we pulled one away and dropped the power there. I guess we could do that, drop it to 0 and drop that to 3. So that is just a new strategy that you could use when solving for greatest common factor, when finding the greatest common factor. You find it, and then you split the number into the greatest common factor times whatever left over to make that, and then you scratch them out, and you use those for your for your answer.